Welcome back to Quotient Rule Part 2. We've established the formula for Quotient Rule, and then we want to see, we've established this one, that we have u over v, and each of them are functions of x. We say that the y, the x is equal to what? V, the u, the x, minus u, the v, the x, all over v squared. So another thing I want to say now, let's imagine if your u is 1, if u is 1, okay, what will happen there? So we are now having now y equal to what? 1 over what? 1 over v. So in that case now, don't forget that this, the u, the x now will be equal to what? 0 here, okay? So if you substitute now, in this place now, you put 0 for the u, the x. So this will go, so and your u is 1, okay? So your formula will now become if y is 1 over v. So your dy, the x will be equal to what? Minus your u is 1, so minus the v, the x over v squared. That is the case when your numerator is 1. So that's the formula for to differentiate that. And I've established that if your u is 1, the u, the x is 0. So put it here, plug in this formula, then you have 1 minus 1 times this one. So that will give you this. So let's have this example to buttress that. If y is 1 over x squared plus 4, find the y, the x. So we'll not waste time with this question. Our u is 1, so we'll just go straight. So your dy be what? Your dy dx will just be equal to what? Minus the b dx over what? Over b squared. Okay? And my dv dx is what? If you differentiate this one, that's what? Minus 2x over what? S squared plus 4 squared. So that's that. For the first one, y equal to, let's make it y. Let y be equal to x plus cos x. So give your question a letter. Let y be equal to this. So my u is what? My u is x plus sine x. Can we get the u, the x, which is equal to 1 plus cos x. Derivative of x is 1, derivative of cos is sine x. What of v? My v is 1 plus cos x. So if you differentiate your v, the v, the x will be equal to what? Minus sine x. So we've established that. Let's quickly differentiate straight away. Y prime will be equal to what? I'm going to have now so we're going to have now we're going to have y prime equal to v from the formula. V is what? 1 plus cos x, that's my v, times the u dx, that's also 1 plus cos x, okay, minus, I'm using this formula, v du dx minus u dv dx all over v squared, okay. My u is x plus sine x, okay, and the v dx is what? Minus sine x all over what? 1 plus cos x. And I've told you we don't expand the denominator except the case 1 and that. So just leave it that way, okay. So this is your v, 1 plus cos x times your du. Your du is what? Your du dx is okay, that's correct. So that will be equal to, if you expand this, that will be 1 plus 2 cos x plus cos square x. Okay, then let's expand this one. Minus, need to be careful here. This one times this one, that's what? Minus x sine x. This one times this one, minus sine square x all over 1 plus cos x square. Okay, and that will be equal to 1 plus 2 cos x plus cos square x minus times this, that's a plus x sin x, and then minus times this plus sin square x all over 1 plus cos x square. So this one and this one plus this one will give me 1. So 1 plus 1, I have 2 here. So my answer to this will be equal to, it's going to give me 2 plus 2 cos x plus x sin x all over 1 plus cos x square. Okay? 1 plus cos x square. So that's that on that question. That's that on that question. We don't have to stress ourselves much. Just leave it that way, because this one cos square x plus sin square is 1. So plus this one, that's 2. So I have 2 plus 2 cos x plus x sin. Yeah, question 2. Y equal to 3 over x plus 1 square. Okay. So my u is 3. So my du dx will be 0. Okay. And then my v is x plus 1 squared. Then the v dx will be equal to, pardon me for now, I'm going to use functions of function. That'll be into bracket x plus 1 times 1. So times 1. So that's functions of function. This one will come to the front. Okay. Times what we have here. And this one minus 1. So that's power 1. Okay. Power 1 here. Okay. And then times the derivative of this. That's 1. Okay. But I'm going to explain that when you get to functions of functions. Okay. So then dy dx will be equal to v du dx minus u dv dx over v squared. My v is what? My v is x plus 1 squared. My u, the u, the x is 0. Minus. So this one cancel out. Minus. My u is 3 times the v dx. The v dx is what? 2 into bracket x plus 1 all over what? All over v squared. My v squared is what? X plus 1 power 4. If you square this one, it becomes power 4. So for your final answer is what? Minus 6 into bracket x plus 1 all over x plus 1 power 4. So this one will cancel, this one will cancel. So we have minus 6 over x plus 1 power 3. 1 has gone here, so power 3. So that's the answer to that. One more questions on this. Yeah, look at the question. Find the gradient of the tangents to the curve. Okay, we have the question v equal to that at the point where theta equal to this. So what we'll do here, this will be so, and though it doesn't matter what letter you use for u or what letter you use for v, it doesn't matter. Okay, you can change the letter if you want. So what we just have to do here is just that we just do it straight away, and that will be equal to v squared. This is the v dx, that's a v prime. That will be equal to cos theta plus sin theta or square. That's my v. That's the denominator square. Then your denominator times your differential coefficient of your numerator, cos theta, then minus the numerator, sin theta, times differential coefficient of your denominator. And if you differentiate this one, it's going to give you minus sin theta plus what? Plus cos theta. The derivative of this one is minus sin theta. The derivative of this one is cos theta. Then let's do the expansion. So this will be equal to cos square theta. This one times this one, cos square theta plus sin theta, cos theta. Then here, minus times minus, that's plus. This one times this one, That's sine square theta. Then minus what? Minus sine theta cos theta all over cos theta plus sine theta all square. So this and this will cancel. Plus and negative negate each other to cancel out. Okay. Then I'm going to have this one plus this one. That's 1. So that's 1 over cos theta plus sine theta square. So that's that on that. Forget the letter we have here is the v, the u, dx minus u, dv, dx over v squared. So that's what we are using. Okay. So minus u is sine theta, and then the differential coefficient of my denominator is this. So what we now do, we have a point there at the point that, so v prime at the point pi over 3. Okay, and that will be equal to 1 over cos pi over 3 plus sine pi over 3 all square. So if you do that, we have 1 over pi over 3 should be 60. So cos 60 is you can use a calculator if you like. Cos 60 is 3 is 1 1 2 2. So cos 60 is adjacent. That's half. That's 1 over 2 plus sine 60 also. Sine 60 is root 3 over 2. Root 3 over 2. That's squared. Okay. Then the next thing to do, let's do that denominator first. Denominator will be equal to 1 plus root 3 over 2. That's for the denominator. Okay. All square. Which will be equal to 1 plus 2 root 3 plus 3 over 4. So the final answer will be equal to, just find the inverse of that. Just find the inverse of that. The inverse of that, so v prime at pi over 3 is equal to what? 4 over 2 root 3 plus 4. 1 plus 3, that's 4. That's 2 root 3 plus 4. Then you can factorize 2 can go here, 2 can go here. So that will be 2 times 2 up there over 2 into bracket 3 plus 2. So that will be 2 here cancel. So we have 2 over 3 plus 2. So that is the answer. You can rationalize it. We have the time. You can rationalize that. You have the time. I'll do that shortly. I just want to look at what we have done so far. By the time you apply that, then at that point, just substitute for theta. Okay, cos theta is half, and sine theta is root 3 over 2. So do this one. We are lucky the denominator is the same, so that will be 2. Okay, and then 1 plus root 3, and then square that. So that will be 1 plus 2 root 3. That will be 1 plus root 3, you bracket it, and then you square, and that will give you this. Okay, over 4, 2 squared over 4. Then find the inverse of that. So, and the 4 at the bottom will go up. By the time you take the inverse. And then 1 plus 3, that's 4. So 4, that's 2 root 3 plus 4. So then you factorize your 2. You take your 2 out. So that's that. You can stop there. But if you want to continue, then you rationalize it. Okay, which will be equal to 2 into bracket root 3 minus 2 all over root 3 plus 2 root 3 minus 2. What I did is I used the conjugate of that denominator to multiply the numerator and denominator. And when we talk of conjugate, we just take the expression and you alternate the sign there. And that was your conjugate. Okay? So I used to multiply bottom and top. So that will give you 2 root 3 minus 4 all over. This will be different of 2 squared. So that will be 3. That will be 3 minus 2. So this is your answer. That's 1. this denominator square, which will be root 3 square, which is 3 minus 2 square. Minus 2 square here, minus 2 square, minus 2 square, that's 3 minus 4, that's minus 1, minus 1. So this answer will now become, to affect this, that will be 2 root 3 plus 4, which is equal to what? 4 minus 2 root 3. So that's 4 minus 2 root 3. So please, if you're new on this channel, please subscribe to this channel. Okay, subscribe to this channel so that as we upload, you get notified. Okay, and again, we are going through the differentiations of three functions. How you can differentiate three functions. Okay, so please join the next video for the differentiations of trigonometry ratio. Okay.